Welcome to our journey through the solar system. Today, we're diving into the incredible world of Mercury, the closest planet to the Sun. Now, you might think that being close to the Sun would make Mercury a scorching, hellish inferno, and you wouldn't be wrong, at least during the day. But Mercury harbors secrets beneath its cratered surface, a world of extremes, from its scorching days to its frigid nights. Let's explore 20 fascinating facts about this swift and mysterious planet. How close is Mercury to the Sun? Earth is 93 million miles away. Mercury, just 36 million miles. On Mercury, the Sun appears 3 times larger than from Earth. This proximity makes Mercury fascinating to study. Mercury is the smallest planet in our solar system. To put things in perspective, if Earth were the size of a nickel, Mercury would be about as big as a blueberry. But don't let its size fool you. This little planet packs a punch when it comes to density. In fact, Mercury is the second densest planet in our solar system, right after Earth. This is because it has a surprisingly large iron core, making up a whopping 85% of its radius. Mercury is a planet of extremes, with wild temperature swings. During the day, it can reach 800 degrees Fahrenheit, hot enough to melt lead. At night, it drops to minus 290 degrees, the most drastic in our solar system. It's due to Mercury's lack of a substantial atmosphere. Chapter 4. A thin veil, Mercury's atmosphere, or lack thereof. When we think of an atmosphere, we imagine a blanket of gas that traps heat and protects a planet. But Mercury's atmosphere is so thin, it's practically non-existent. It's what scientists call an exosphere, a wispy collection of atoms. This exosphere is so thin that atoms escape into space, constantly replenished by the solar wind. Without a substantial atmosphere, Mercury's surface experiences the full brunt of the Sun's energy. Chapter 5. A day longer than its year. Here on Earth, a day is 24 hours. But on Mercury, things are different. A day on Mercury takes 59 Earth days. A year on Mercury is only 88 Earth days. So a day on Mercury is longer than its year. Chapter 6. A solitary traveler, no moons or rings for Mercury. Our solar system is diverse, with planets boasting a variety of companions. Jupiter and Saturn are surrounded by rings and moons. But Mercury prefers to travel solo. This little planet has no moons or rings, it's just Mercury orbiting the Sun in solitary splendor. Chapter 7. An elliptical journey. Most planets in our solar system follow circular paths around the Sun, but Mercury traces out the most elliptical orbit of all the planets. Mercury's distance from the Sun varies significantly throughout its 88-day year. This elliptical orbit, combined with Mercury's slow rotation, creates bizarre effects on the planet's surface. Chapter 8. A scarred and cratered surface. If you could take a trip to Mercury, you'd be greeted by a desolate yet strangely beautiful landscape. Mercury's surface is heavily cratered, resembling our own moon, a testament to billions of years of impacts from asteroids, comets, and other space debris. These craters range in size from small bowl-shaped depressions to vast impact basins hundreds of miles across. But Mercury's surface isn't just a collection of craters. It's also home to smooth plains, towering cliffs known as lobate scarps, and even evidence of ancient volcanic activity. Chapter 9. Caloris Basin, a scar to remember. Among Mercury's many features, one stands out, the Caloris Basin. This colossal impact basin stretches 960 miles across. It's about the size of the continental United States. The impact released enough energy to melt rock and reshape Mercury's surface. For centuries, Mercury remained a largely mysterious world, its secrets hidden behind its proximity to the Sun. But in 2011, NASA's Messenger spacecraft arrived at Mercury, becoming the first spacecraft to orbit the innermost planet. Over the next 4 years, Messenger revolutionized our understanding of Mercury, beaming back stunning images and a wealth of data. Messenger mapped Mercury's surface in unprecedented detail, studied its composition, measured its magnetic field, and provided crucial insights into the planet's formation and evolution. On Earth, we experience distinct seasons due to our planet's axial tilt. But Mercury doesn't get the whole seasons thing. Mercury's axial tilt is a mere 2 degrees. This means Mercury doesn't experience significant seasonal changes. The sun's rays hit the planet at almost the same angle year-round. Earth's magnetic field acts like a giant shield, protecting us from harmful solar radiation. And while Mercury does have a magnetic field, it's a bit of an underachiever. Mercury's magnetic field is about 1% as strong as Earth's, which is surprising given its large iron core. Scientists believe that Mercury's weak magnetic field is likely due to its slow rotation. The planet's core may have partially solidified over billions of years, slowing down the churning of molten iron that generates a magnetic field. Deep beneath Mercury's cratered surface lies a secret, a massive iron core. This core is estimated to make up about 85% of the planet's radius, giving Mercury the highest density of any planet in our solar system, except for Earth. Scientists believe that this iron core formed early in Mercury's history, when the planet was still a molten ball of rock and metal. As Mercury cooled, denser materials like iron sank toward the center, forming the core we see today. In the early 20th century, Albert Einstein revolutionized our understanding of gravity with his theory of general relativity. One of the key predictions of Einstein's theory was that the orbits of planets around the Sun are not perfectly elliptical, but rather shift slightly over time, a phenomenon known as perihelion precession. And guess what? Mercury provided the first observational evidence of this effect. Astronomers had long been puzzled by a slight wobble in Mercury's orbit that couldn't be explained by Newtonian physics. But Einstein's theory neatly accounted for this wobble, providing a stunning confirmation of general relativity. While Mercury might seem like a dead and inactive world, there's evidence to suggest that it had a more fiery past. Scientists have found vast plains on Mercury's surface that appear to be composed of solidified lava flows, indicating that volcanic activity played a significant role in shaping the planet's early history. These volcanic plains are some of the smoothest features on Mercury, suggesting that they formed from eruptions that occurred after the period of heavy bombardment that created most of the planet's craters. Despite its small size, Mercury has a surprisingly strong gravitational pull. In fact, Mercury's surface gravity is about 38% of Earth's gravity. This means that if you could stand on the surface of Mercury, you'd weigh about 38% of what you weigh on Earth. While this might sound fun at first, keep in mind that you'd still need a spacesuit to survive the extreme temperatures and lack of atmosphere. As you explore Mercury's surface, you'll encounter towering cliffs known as scarps. These scarps can stretch for hundreds of miles and rise up to a mile high. Scientists believe that these scarps formed as Mercury's interior cooled and contracted over billions of years. This contraction caused the planet's crust to buckle and fold, creating the dramatic cliffs we see today. These scarps are a testament to the immense forces that have shaped Mercury over its long history. Here on Earth, we experience a wide range of weather phenomena, from gentle breezes to raging storms. But on Mercury, the weather forecast is always the same: no weather at all. This is because Mercury lacks a substantial atmosphere to drive weather patterns. Without an atmosphere to trap heat and distribute energy, there are no winds, storms, or precipitation on Mercury. It's a silent and still world, its surface exposed to the harshness of space. Mercury's rotation is tidally locked to the Sun in a unique 3-to-2 resonance. This means that for every 3 rotations on its axis, Mercury completes 2 orbits around the Sun. This unusual resonance is due to the Sun's powerful gravitational influence, which has slowed down Mercury's rotation over billions of years. This 3-to-2 spin cycle creates some bizarre effects on the planet's surface, with certain points experiencing prolonged periods of daylight and darkness. Mercury has been known to humans since ancient times, its bright light visible in the twilight sky. The earliest recorded observations date back to the Sumerians around 3000 BC. The Greeks named the planet Hermes after their swift-footed messenger god. The Romans later adopted the name Mercury, associating it with their own messenger god. Thanks for joining us on this journey to Mercury. We hope you enjoyed learning about this fascinating planet. From its scorching temperatures to its weak magnetic field, Mercury is a planet of extremes, a testament to the incredible diversity of our solar system. While we've only scratched the surface of what there is to know about Mercury, we hope this journey has sparked your curiosity about this enigmatic world. Don't forget to like, subscribe, and hit the bell icon for more space adventures. See you next time.